Hello there. Tonight we're drifting beyond our solar system, beyond the familiar worlds of Mars and Jupiter, into the vast ocean of space where thousands of distant planets orbit alien suns. These are the exoplanets, worlds so far away that their light takes years, decades, even centuries to reach us. Some are scorching hot, others frozen solid. Some are made of diamond and glass, others float like cosmic balloons through the darkness. Each one carries secrets written in starlight, stories of distant skies and alien sunsets that no human eye has ever seen. Tonight we'll explore these peaceful worlds together, letting their quiet mysteries wash over you like waves on a distant shore. If you enjoy drifting off to the wonders of space, feel free to like and subscribe or simply share your thoughts in the comments below. It helps other stargazers find their way here too. But for now, let these distant worlds carry you gently towards sleep. And if you're ready, let's begin our journey to the stars. There are planets made entirely of water floating silently through space. Imagine a world where no land exists at all, where endless oceans stretch from horizon to horizon beneath alien skies. These water worlds, detected by the way they bend and filter starlight, may be more common than we ever imagined. Some orbit so close to their stars that their surfaces boil into permanent steam clouds. Others drift so far away that their oceans freeze solid, creating spheres of ice floating through the cosmic void. The most peaceful of these water worlds exist in what astronomers call the habitable zone, that perfect distance where liquid water can exist peacefully on the surface. Here, gentle waves might lap against floating islands of ice, and strange currents could carry microscopic life through endless blue depths. The gravity on these worlds could be so gentle that their oceans would be deeper and calmer than any sea on Earth, creating vast underwater landscapes where light filters down through thousands of feet of crystal clear water. On these distant shores, if shores exist at all, the sunsets would paint the endless waters in colors we've never seen. The parent star might be smaller and redder than our sun, casting everything in warm amber light. Or it might be larger and bluer, turning the oceans into mirrors that reflect brilliant sapphire skies. Without continents to break them, the waves on these worlds could travel completely around the planet, creating a rhythm of water and light that has continued unbroken for millions of years. Some exoplanets experience eternal twilight, caught between day and night forever. These tidally locked worlds always show the same face to their star, just like our moon always shows the same face to Earth. On one side, the sun never sets, creating a hemisphere of permanent day. On the other side, darkness reigns eternal, with temperatures so cold that the very air might freeze and fall as snow. But it's the boundary between these two worlds where magic happens. Along the Terminator line, the edge between light and dark, exists a ring of perpetual sunset. Here the star hangs forever on the horizon, painting the sky in endless shades of orange and red. The temperature is neither too hot nor too cold, and gentle breezes flow from the warm side to the cold side, creating the most peaceful weather patterns imaginable. On these twilight worlds, you could stand in one spot and watch the same beautiful sunset for hours, days, even years. The clouds would drift slowly across skies that never fully darken and never grow fully bright. Strange aurora might dance overhead, created by the planet's magnetic field interacting with particles from its star. The landscape would be bathed in soft, warm light that never changes, creating shadows that remain perfectly still like a photograph frozen in time. If there were oceans on these worlds, they would be strange and wonderful. On the day side, they might bubble and steam, creating clouds that drift toward the night side where they freeze and fall as snow. This snow would pile up over millions of years, creating vast glaciers that slowly flow back toward the warm side, melting into rivers that feed the eternal ocean. It would be a cycle of water and ice driven by the planet's unique relationship with its star. A slow dance of elements that has continued since the world was young. There are diamond planets where crystal rain falls from metallic skies. These carbon-rich worlds formed in regions of space where carbon was more abundant than the oxygen that creates our familiar rocky planets. Instead of silicon and metals, these worlds are made primarily of carbon in its various forms, including vast amounts of diamond. On these sparkling worlds, the surface might be covered in graphite plains and diamond mountains that catch and reflect the light of their star. The atmospheric pressure and temperature could be just right to create clouds of tiny diamond crystals that fall like glittering snow. Each storm would be a shower of precious stones, creating drifts of diamonds that sparkle in the alien sunlight. The rivers on these worlds wouldn't be made of water, but of liquid carbon compounds that flow like oil, carving valleys through landscapes of pure carbon. These dark streams would wind between hills of diamond and graphite, creating a black and white world of stunning contrasts. When the star rises, every surface would catch the light and throw it back in brilliant flashes, making the entire planet sparkle like a jewel hanging in space. The gravity on these diamond worlds might be different from Earth, creating strange weather patterns where diamond dust could float in the air like glittering fog. Walking through such an environment would be like moving through a cloud of stars, with every breath filled with microscopic crystals that catch the light. The sunsets would be particularly spectacular, as the diamond particles in the atmosphere would split the starlight into rainbows that dance across the sky. Some of these carbon worlds might have diamond cores so large and pure that they ring like bells when struck by meteors, sending musical vibrations through the planet that continue for hours. The entire world would become a cosmic instrument, playing slow, deep melodies that echo through space at frequencies too low for human ears to hear directly, but felt as gentle vibrations that could lull you to sleep. Gas giants with floating cloud cities drift through space like cosmic balloons. These worlds have no solid surface at all, just layer upon layer of colorful gases that swirl in endless patterns. Some are larger than Jupiter, with atmospheres so thick that the pressure at the bottom creates exotic forms of matter that exist nowhere else in the universe. Others are smaller and lighter, floating through space like soap bubbles filled with strange and beautiful gases. The most peaceful of these worlds have gentle atmospheric currents that create bands of color stretching around the entire planet. These bands might be made of methane clouds that glow softly in the starlight, or ammonia crystals that form delicate patterns like frost on a window. The colors would shift slowly over time as the gases mix and separate, creating a constantly changing work of art painted across the sky. On these gas worlds, storms the size of continents drift peacefully through the atmosphere, but unlike the violent hurricanes of Jupiter, these might be gentle spirals of warm gas that glow with their own internal light. They could persist for thousands of years, slowly rotating and changing color as they encounter different layers of the atmosphere. From space, these storms would look like flowers blooming in slow motion across the face of the planet. The most fascinating aspect of these gas worlds is the possibility of floating life. In the warm, dense layers of the atmosphere, simple organisms might drift like plankton in an ocean of air. These sky whales could be vast creatures that feed on the chemical energy in the atmosphere, glowing softly as they swim through clouds of gas. They might sing to each other using sound waves that travel for thousands of miles through the dense atmosphere, creating songs that last for days and can be heard from one side of the planet to the other. The sunrises on these gas worlds would be unlike anything we can imagine on Earth. As the star's light filters through hundreds of miles of colored gases, it would create layers of light that shift and change like aurora. The entire sky might glow in shades of green and blue and purple, with the star itself appearing as a soft disk that seems to float in an ocean of color. There would be no sharp shadows here, just gentle gradations of light that make everything appear soft and dreamlike. Planets covered in endless crystal forests stretch across alien continents. These silicon-based worlds formed in the cold outer regions of their solar systems, where unusual chemistry allowed vast crystal structures to grow directly from the planet's surface. Instead of trees made of wood and leaves, these worlds might be covered in towering spires of quartz and amethyst that ring like wind chimes when the breeze passes through them. These crystal forests would be places of incredible beauty and tranquility. The trees might be transparent or translucent, allowing light to pass through them and create rainbow patterns on the forest floor. When the star rises, the entire forest would light up like a chandelier, with every crystal surface catching and reflecting light in brilliant cascades of color. The effect would be like walking through a cathedral made entirely of stained glass. The wildlife on these crystal worlds might be equally crystalline. Creatures made of living minerals could grow and move by rearranging their crystal structure, changing shape and color as they travel through their sparkling environment. They might communicate by creating specific patterns of light and color, turning the entire forest into a vast network of glowing signals that pulse gently through the crystal matrix. The weather on these worlds would be unique and peaceful. Instead of rain, tiny crystal seeds might fall from the sky, taking root in the ground and slowly growing into new crystal formations. The seasons would be marked not by changing leaves, but by changing colors as different minerals become active at different temperatures. Winter might turn the forest deep blue and purple, while summer could make everything glow warm gold and orange. The most beautiful feature of these crystal worlds would be their music. Every breeze would cause the crystal formations to vibrate and ring, creating harmonious chords that echo through the forest. Different areas would have different tones, creating a planetary symphony that changes with the weather and the seasons. Standing in such a forest would be like being inside a massive musical instrument that plays itself, filling the air with gentle melodies that seem to come from the very structure of the world itself. Super Earths with gentle gravity and extended seasons drift through space at a leisurely pace. These worlds are larger than our planet, but smaller than the gas giants, creating unique conditions that might be even more hospitable to life than Earth itself. Their increased size means stronger gravity, but not so strong as to be uncomfortable. It would be like carrying a gentle weight that makes every movement more deliberate and graceful. The extended seasons on these super Earths come from their larger orbits and different relationships with their stars. A single year might last several Earth years, allowing each season to develop fully and create incredibly stable weather patterns. Spring could last for months with gentle rains and slowly warming temperatures that allow life to emerge gradually from winter's rest. Summer would be a long, peaceful time of warmth and growth, while autumn could stretch on for half an Earth year, painting vast continents in colors that slowly deepen and change. The landscapes on these super-Earths would be shaped by their gentle gravity and long seasons. Mountains might be taller and more graceful, rising slowly from vast plains that stretch beyond the horizon. Rivers would flow more slowly and carve deeper valleys, creating landscapes of incredible beauty and stability. The extended seasons would allow for the development of complex ecosystems that have time to establish deep, intricate relationships between different forms of life. The night skies of these super-Earths would be spectacular. Their larger size and different orbital characteristics might give them multiple moons, creating complex tidal patterns and night skies filled with dancing lights. The auroras on these worlds could be more frequent and more beautiful, as their stronger magnetic fields interact with particles from their star to create curtains of light that ripple across the sky for hours at a time. The most peaceful aspect of these super-Earths would be their stability. The longer seasons and stronger gravity would create weather patterns that change very slowly, allowing for the development of incredibly stable ecosystems. A forest on one of these worlds might remain essentially unchanged for thousands of years, growing slowly and peacefully under the patient light of an alien sun. The very pace of life would be different, more contemplative and serene, shaped by the gentle rhythms of a world that has all the time in the universe. Frozen worlds spin silently through the darkness, their surfaces covered in exotic ices that exist nowhere in our solar system. These distant planets orbit far from their stars, where temperatures drop so low that the very atmosphere freezes and falls like snow. But these aren't the familiar water ice we know on Earth. Instead, these worlds are covered in frozen methane, nitrogen, and even frozen carbon dioxide that creates landscapes of surreal beauty. The methane ice on these worlds forms in delicate patterns that catch what little starlight reaches the surface. It might create vast plains that sparkle like fields of diamonds or form intricate frost patterns that cover entire continents in lace-like designs. The surface would be so smooth and reflective that walking across it would be like walking on a mirror that stretches to the horizon, creating the illusion that you're floating through space itself. The most peaceful aspect of these frozen worlds is their absolute stillness. With no liquid water to create weather, no wind to disturb the surface, these planets exist in a state of perfect quiet. The only sounds would be the occasional crack of expanding ice or the whisper of nitrogen snow falling so slowly in the low gravity that each flake takes minutes to reach the ground. It would be like being inside a cosmic snow globe where time moves at the pace of dreams. Some of these frozen worlds experience rare warming events when their elliptical orbits bring them slightly closer to their star. During these brief summers that occur perhaps once every 1,000 years, the surface begins to sublimate, creating temporary atmospheres of exotic gases. For a few short decades, these dead worlds come alive with gentle winds and swirling clouds before slowly freezing again as they drift back into the cold depths of their orbit. The beauty of these worlds lies in their temporary nature. The ice formations that take centuries to form can disappear in a matter of years during these warming periods, only to reform in new and different patterns as the world freezes once again. It's a cycle of creation and destruction so slow that entire civilizations could rise and fall in the time it takes for one season to pass on these distant, dreaming worlds. Rogue planets wander freely through interstellar space, unbound by any star. These orphaned worlds were ejected from their birth systems billions of years ago and now drift alone through the galaxy, carrying no light except the faint glow of their own internal heat. They exist in the spaces between stars, in the vast emptiness where no telescope can easily find them, traveling on journeys that will last until the end of time itself. Despite their isolation, these rogue worlds might be among the most peaceful places in the universe. With no star to create weather patterns or seasonal changes, they exist in a state of eternal equilibrium. Any atmosphere they possess would be perfectly still. Any oceans would be covered in permanent ice, and the surface would know a tranquility that no planet bound to a star could ever achieve. The most remarkable thing about rogue planets is that they might harbor life beneath their frozen surfaces. The internal heat generated by radioactive decay could keep subsurface oceans liquid for billions of years. These hidden seas would be completely isolated from the universe above, creating unique ecosystems that evolved in total darkness and perfect solitude. Life on these worlds would know nothing of day and night, seasons, or the light of stars. It would exist in a state of perpetual meditation, sustained only by the gentle warmth rising from the planet's core. The journey of a rogue planet through space is perhaps the most contemplative voyage imaginable. Over millions of years, they pass through different regions of the galaxy, sometimes approaching other star systems and witnessing the birth and death of worlds, but never stopping, never being captured. They are the universe's wanderers, carrying their secrets through the cosmic dark, perhaps occasionally passing close enough to another rogue world to exchange a gravitational greeting before continuing on their separate paths through infinity. Standing on the surface of such a world would offer a view of the universe unlike anywhere else. With no nearby star to wash out the sky, the view of space would be unobstructed and absolute. The Milky Way would stretch overhead in all its glory, and distant galaxies would be visible to the naked eye. It would be like having a front row seat to the entire universe, a private observation deck floating through the cosmos where you could contemplate the full majesty of creation in perfect silence. Binary worlds dance together in gravitational embrace, two planets sharing the same orbit around their star. These cosmic partners are so close that they raise massive tides on each other's surfaces, creating landscapes that pulse and flow with the rhythm of their orbital dance. The smaller world might be so close to its partner that it appears to fill half the sky, creating sunrises and sunsets that are painted not just by their star, but by the light reflecting off their companion world. The tidal forces between these binary planets create some of the most dynamic and beautiful landscapes in the universe. On worlds with oceans, the water would rise and fall in massive tides that could be hundreds of feet high, creating temporary seas that appear and disappear with the rhythm of the orbital dance. Mountain ranges might flex and bend under the gravitational stress, creating valleys that open and close like breathing, and geysers that erupt on schedule as the tidal forces squeeze and release the planet's interior. The weather patterns on binary worlds would be unlike anything we could imagine on a single planet. The gravitational pull between the two worlds would create atmospheric currents that flow not just around each planet, but between them. During close approaches, the atmospheres might actually touch, creating bridges of air that allow weather systems to transfer from one world to the other. Storms could literally travel through space from one planet to its partner, carrying rain and wind across the vacuum between worlds. The most peaceful moments on binary worlds would occur during the periods of perfect synchronization, when both planets are aligned with their star and each other. During these rare events, the tidal forces would be in perfect balance, creating a brief period of calm when the seas would be still and the earth would stop its flexing. These moments of perfect harmony might last for only a few hours, but they would be times of extraordinary beauty when both worlds exist in perfect equilibrium. The sunsets on binary worlds would be spectacular beyond imagination. As the star sets behind one world, its companion might be rising on the opposite horizon, creating a sky that transitions from the warm colors of sunset to the cool, reflected light of the partner world. Sometimes both the star and the companion planet might be visible simultaneously, creating double sunsets where the sky is painted in layers of color that blend and shift as the celestial dance continues overhead. Ocean worlds with floating continents drift peacefully beneath alien skies, their land masses made not of rock but of vast mats of organic material that have grown and merged over millions of years. These biological continents float on seas that might be hundreds of miles deep, rising and falling with currents that circle the globe in patterns more complex and beautiful than any weather system on Earth. The floating continents on these worlds would be like living islands, constantly growing and changing as new organic material is added to their edges. They might be covered in forests of coral-like structures that filter nutrients from the water, or vast meadows of seagrass that wave gently in the ocean breezes. The entire landmass would be alive, breathing and growing and responding to the rhythms of the sea. The oceans beneath these floating continents would be crystal clear and incredibly deep, filled with layers of life that exist at different depths. Near the surface, the water might be warm and bright, supporting ecosystems that depend on sunlight. But in the deeper layers, bioluminescent creatures could create their own light, turning the depths into a living galaxy of stars that pulse and twinkle in the eternal darkness below. The weather on these ocean worlds would be gentle and predictable, driven by the vast thermal mass of the global sea. Storms would be rare and mild, mostly consisting of warm rain and gentle winds that help distribute nutrients across the floating continents. The seasons would be marked not by temperature changes, but by shifts in ocean currents that bring different nutrients to different parts of the world, creating blooms of life that paint the continents in ever-changing patterns of color. The most beautiful feature of these worlds would be their bioluminescent displays. During certain seasons or lunar cycles, the entire ocean might light up with living creatures that create patterns of light visible from space. The floating continents would become stages for these displays, with waves of color washing across their surfaces as billions of tiny organisms pulse in synchronized rhythm. From the surface, it would look like the aurora has descended into the sea, creating curtains of living light that dance beneath the waves. Worlds with glass beaches stretch along coastlines where sand has been transformed into smooth, colored glass by the intense radiation of nearby stars. These planets exist in the habitable zones of stars much more energetic than our Sun, where the constant bombardment of high-energy particles has fundamentally altered the surface chemistry over millions of years. The glass beaches on these worlds would be places of incredible beauty and tranquility. Instead of rough sand that shifts and moves, the beaches would be made of billions of tiny glass spheres that have been smoothed and polished by eons of wave action. These glass particles would come in every color imaginable, created by different trace elements in the original sand that were transformed by the stellar radiation. Walking on such a beach would be like walking on a surface made of liquid mercury that has been frozen into perfect smoothness. The waves on glass beach worlds would create sounds unlike anything heard on Earth. Instead of the familiar crash and hiss of water on sand, the waves would create musical tones as they wash over the glass surface. Each wave would be like a bow drawn across the strings of a cosmic violin, creating harmonies that change with the size and energy of the waves. The entire coastline would become a musical instrument played by the sea itself. The sunlight on these worlds would create spectacular optical displays as it passes through the glass beaches. During sunrise and sunset, the entire shore would light up like a prism, breaking the starlight into rainbows that dance and shift with every wave. The glass particles would act like millions of tiny lenses, creating patterns of focused light that move across the beach like living things, painting temporary pictures in light that last for only moments before dissolving into new patterns. The most peaceful aspect of glass beach worlds would be their incredible clarity. The glass sand would create water so clear that you could see to the bottom of the deepest pools, and the lack of suspended particles would make the air crystal clear as well. The entire world would have the quality of being seen through the finest optical instruments, with every detail sharp and perfectly defined. It would be like living inside a work of art where every surface has been polished to perfection. Methane worlds glow softly in the light of distant red dwarf stars, their surfaces painted in shades of amber and gold that shift gently with the changing chemistry of their atmosphere. These hydrocarbon-rich planets exist in a state of perpetual twilight, where the weak light of their small stars creates a warm, honey-colored glow that bathes everything in soft, dreamlike illumination. The methane lakes on these worlds would be perfectly still, their surfaces like mirrors that reflect the golden sky without a single ripple. Unlike the violent storms of Titan in our own solar system, these distant methane worlds might experience only the gentlest of weather patterns. Slow-moving clouds of organic compounds would drift across the sky like cotton balls soaked in amber light, casting soft shadows that move across the landscape at the pace of meditation. The rain on these worlds would be unlike anything we know. Instead of water, drops of liquid methane and ethane would fall from the golden clouds, each droplet catching the light of the red dwarf star and glowing like a tiny lantern as it falls. These hydrocarbon rains would create rivers that flow like liquid honey, carving valleys through landscapes made of frozen organic compounds that sparkle in the perpetual twilight. The most remarkable feature of these methane worlds would be their incredible stability. Red dwarf stars burn for trillions of years, far longer than stars like our sun, which means these golden worlds could maintain their peaceful state for eons beyond our imagination. The same gentle twilight, the same amber skies, the same quiet rain falling on the same still lakes, unchanged for periods of time so vast that entire galaxies could be born and die while these worlds continue their quiet existence. The atmosphere on these worlds would be thick enough to create fascinating optical effects. The methane and other organic compounds would act like a natural filter, softening all the light and creating an environment where harsh shadows simply cannot exist. Everything would be bathed in the same warm, golden glow, creating a world that feels like being inside a cosmic amber jewel, where time moves slowly and all sharp edges have been smoothed away by eons of gentle chemistry. Tidally heated moons orbit massive gas giants, their surfaces kept warm not by starlight but by the constant flexing of gravitational forces. These worlds exist in the cold outer regions of their solar systems, far from their stars, yet they remain surprisingly active and warm due to the cosmic dance they perform with their giant parent planets. The most peaceful of these moons would experience tidal heating so gentle that it creates a perfectly stable internal temperature. The surface might be covered in warm springs that never freeze, even in the depths of space far from any star. These thermal oases would create pockets of liquid water surrounded by ice, forming natural hot tubs that could maintain their temperature for millions of years through the patient pull of gravitational forces. The landscapes on tidally heated moons would be shaped by this internal warmth in beautiful and unexpected ways. Geysers might erupt on predictable schedules, timed to the orbital rhythm of the moon around its planet. These eruptions would be gentle and regular, like the breathing of the world itself, sending plumes of warm water vapor into the thin atmosphere where it would freeze and fall back as snow, only to be melted again by the next wave of tidal heating. The most extraordinary feature of these moons would be their underground oceans, vast seas of liquid water hidden beneath shells of ice. These subsurface oceans would be kept liquid by the gentle massage of tidal forces, creating environments that could remain stable for billions of years. The water in these hidden seas would be in constant, slow motion, driven by currents that flow in patterns determined by the gravitational relationship between the moon and its parent planet. The auroras on these tidally heated moons would be particularly spectacular. The interaction between the moon's thin atmosphere and the powerful magnetic field of its giant parent planet would create displays of light that dance across the sky in patterns that repeat with the orbital period. These auroras would be the moon's way of singing, a visual representation of the gravitational forces that keep it warm and active in the cold depths of space. Worlds with slow rotation experience days that last for months, creating weather patterns so gradual and peaceful that storms develop and dissipate over periods that would span entire seasons on Earth. These leisurely planets take their time with everything from sunrise to sunset, creating environments where change happens so slowly that it's almost imperceptible. On slow-rotating worlds, the sunrise would be an event that unfolds over weeks. The star would creep so slowly across the sky that you could watch it move from hour to hour, painting the landscape in colors that shift gradually from the deep purples of dawn through the golds of morning and into the bright whites of midday. The sunset would be equally prolonged, a cosmic farewell that takes its time, allowing every moment to be savored and appreciated. The weather systems on these worlds would develop with the patience of geological processes. A storm cloud might take days to form, gathering moisture and energy so slowly that its approach could be predicted months in advance. When storms finally do arrive, they would be gentle affairs, with rain that falls steadily for weeks and winds that blow with the consistency of a patient breath. There would be no sudden changes, no violent weather, just the slow, predictable rhythm of a world that refuses to be hurried. The seasons on slow-rotating planets would be incredibly long and stable. Spring might last for what we would consider years, allowing ecosystems to develop complex relationships and reach states of perfect balance before slowly transitioning into summer. Each season would have time to fully mature, creating environments that are incredibly rich and stable because they have the luxury of time to develop without interruption. The most peaceful aspect of these worlds would be their sense of permanence. On a planet where day and night each last for months, where seasons stretch across years, and where weather systems develop over decades, everything would have a quality of eternal stability. It would be like living in a slow-motion movie where every gesture has weight and meaning, where there's always time to appreciate each moment because each moment lasts so much longer. Helium planets float through space like cosmic soap bubbles, their atmospheres so light that they barely hold together against the pull of space. These unusual worlds formed in regions where lighter elements were more abundant, creating planets that are more like atmospheric phenomena than solid worlds. They drift through their orbits with an ethereal quality, as if they might dissolve back into space at any moment. The helium atmosphere on these worlds would create unique and beautiful effects. Sound would travel differently through the light gas, creating an environment where voices would be higher and clearer, and where music would take on qualities impossible to achieve in any other atmosphere. The entire world would exist in a state of acoustic wonder where every sound is transformed and enhanced by the unusual properties of the helium-rich air. The weather patterns on helium planets would be unlike anything we could imagine. The light atmosphere would be incredibly responsive to temperature changes, creating cloud formations that appear and disappear like thoughts, and winds that flow in patterns determined more by thermal currents than by the rotation of the planet. The entire atmospheric system would be delicate and ephemeral, like living in a world made of breath and dreams. The most remarkable feature of these helium worlds would be their relationship with light. The helium atmosphere would interact with starlight in unique ways, creating optical effects that make the entire world seem to glow from within. The sky might appear to shimmer and dance, with colors that shift and change as the light passes through the unusual atmospheric chemistry. It would be like living inside a soap bubble surrounded by iridescent beauty that changes with every shift of perspective. The gravity on helium planets would likely be very gentle, allowing the light atmosphere to extend far into space without being pulled down to the surface. This would create worlds where the boundary between atmosphere and space is gradual and indefinite, where you could theoretically float upward through increasingly thin air until you found yourself among the stars. It would be like living on a world that's trying to return to the cosmic gas cloud from which it formed. Crystal cave worlds hide vast underground chambers lined with formations that have grown undisturbed for millions of years. These planets appear ordinary from space, but beneath their surfaces lie cathedral-sized caverns where conditions have remained perfectly stable for geological ages, allowing crystal formations to reach sizes and complexities impossible on worlds with more active geology. The crystal caves on these worlds would be places of absolute silence and perfect beauty. The formations would have grown so slowly and carefully that they would be flawless, creating underground palaces where every surface reflects and refracts light in patterns of mathematical precision. The caves would be like natural cathedrals carved by time itself, with crystal columns that reach from floor to ceiling and formations that create acoustic spaces where the slightest whisper would be transformed into ethereal music. The underground rivers on these worlds would flow through crystal channels that have been polished smooth by millions of years of gentle currents. The water would be incredibly pure, filtered through layers of crystal until it becomes as clear as the formations themselves. These streams would create soft, musical sounds as they flow over and around the crystal formations, adding a gentle soundtrack to the underground paradise. The most extraordinary aspect of these crystal cave worlds would be their light displays. Deep beneath the surface, where no starlight can reach, the caves would be illuminated by phosphorescent minerals and bioluminescent life forms that have adapted to the underground environment. The crystal formations would act like fiber optic cables, carrying this light throughout the cave system and creating displays that rival the aurora but exist in perfect stillness, far below the surface. The temperature in these crystal caves would be perfectly stable, maintained by the planet's internal heat and insulated by layers of rock and crystal. This stability would create environments where delicate formations could grow undisturbed, where underground lakes could remain liquid for eons, and where any life that did evolve would exist in a state of perfect balance with its crystalline environment. Worlds with retrograde rotation spin backwards compared to their orbital motion, creating unique day-night cycles where the sun rises in what would normally be considered the west and sets in the east. These backward spinning worlds march to their own cosmic rhythm, creating environments where the familiar relationship between day and night, seasons and weather, is turned upside down in beautiful and unexpected ways. The weather patterns on retrograde worlds would be fundamentally different from those on normally rotating planets. The backward spin would create atmospheric currents that flow in directions opposite to what we might expect, generating storm systems that spiral in reverse and creating climate patterns that are mirror images of what we see on forward-spinning worlds. These reversed weather systems would be no less beautiful or peaceful, just different, like seeing familiar music played in a minor key. The Coriolis effect on retrograde worlds would create oceanic currents that flow in patterns unlike anything seen on Earth. These reverse currents would distribute heat and nutrients in unique ways, potentially creating more stable and uniform climate conditions because the backwards rotation would mix the atmosphere and oceans in ways that prevent extreme temperature differences from developing. The most peaceful aspect of retrograde rotation would be its effect on the length of days. Depending on the speed of rotation and orbital motion, these worlds might experience very long days and nights, creating extended periods of warming and cooling that would result in incredibly stable weather patterns. The backward spin would create a world that seems to be taking its time with everything, moving through its daily cycle with deliberate patience. The sunrises and sunsets on retrograde worlds would occur in directions that would seem backwards to us, but this difference would create unique opportunities for beauty. Mountain ranges that would normally be backlit during sunset would instead be frontlit, creating entirely different lighting conditions and revealing landscape features in ways that forward-spinning worlds never could. It would be like seeing familiar beauty from a completely new perspective. Ammonia snow worlds exist in the cold outer reaches of their solar systems, where temperatures are so low that ammonia freezes and falls like snow, creating landscapes covered in white crystals that sparkle in the faint light of distant stars. These worlds would be places of pristine beauty, where the ammonia snow never melts and accumulates over millions of years into drifts and formations of incredible purity and geometric perfection. The ammonia snow on these worlds would be different from any precipitation we know. Each flake would be a perfect crystal with its own unique structure, and the snow would be so light and fine that it would drift in the slightest breeze like powder, creating landscapes that seem to shift and change like living things. The accumulated snow would be so pure that it would be almost transparent, creating surfaces that seem to glow with their own internal light. The atmosphere on ammonia snow worlds would be thin and incredibly clear, allowing views of space that are unobstructed by clouds or haze. The snow-covered surface would reflect what little starlight reaches these distant worlds, creating an environment that is softly illuminated even in the depths of space. It would be like living in a cosmic snow globe where everything is white and pure and perfect. The wind patterns on these worlds would create amazing formations in the ammonia snow. Like sand dunes in a desert, but made of snow so fine that it behaves almost like a liquid, these formations would shift and change over time, creating temporary sculptures that exist for centuries before being reshaped by the patient winds. The landscape would be in constant slow motion, always changing but never hurried. The most beautiful feature of ammonia snow worlds would be their absolute silence. With no liquid water to create weather, no volcanic activity to disturb the peace, and atmospheres too thin to carry sound very far, these worlds would exist in a state of perfect quiet. The only sounds would be the whisper of snow crystals brushing against each other in the wind, creating a soft susurrus that is more felt than heard, like the breathing of the world itself. Hot Jupiter worlds that have migrated inward from cold outer orbits now exist in states of extreme atmospheric activity, with winds that circle the planet at speeds that would be devastating on Earth but create their own strange beauty in the alien environment. These massive gas giants orbit so close to their stars that their atmospheric chemistry has been fundamentally altered by the intense radiation and heat. Despite their extreme conditions, these hot Jupiters possess a kind of violent beauty that becomes peaceful when viewed from the proper perspective. Their atmospheric bands, heated to incandescence by their nearby stars, glow with their own light in colors that shift from deep red through orange and yellow to brilliant white. The entire planet becomes a living display of thermodynamics, where temperature differences create patterns of stunning complexity and beauty. The day-night temperature differences on these worlds create atmospheric flows unlike anything in our solar system. Winds race around the planet at thousands of miles per hour, carrying heat from the day side to the night side in a continuous circulation that never stops. These supersonic winds create pressure waves and atmospheric patterns that would be visible from space as bands and spirals of glowing gas that shift and change in hypnotic rhythms. The most fascinating aspect of hot Jupiters is their atmospheric composition, which has been altered by the intense stellar radiation. Elements that would normally be solid at lower temperatures exist as gases in their atmospheres, creating clouds made of exotic materials like vaporized metals and silicates. These unusual clouds create colors and optical effects that exist nowhere else in the universe, painting the sky in shades of metallic silver and gold. The auroras on hot Jupiter worlds would be incredible beyond description. The interaction between the planet's magnetic field and the intense stellar wind would create displays of light that cover significant portions of the planet's surface. These auroras would be visible continuously, creating a permanent light show that dances across the upper atmosphere in patterns that mirror the planet's internal magnetic structure. The most peaceful way to appreciate these extreme worlds is to imagine viewing them from a safe distance, where their violence becomes art and their chaos becomes beauty. From the right perspective, a hot Jupiter is not a hellish world, but a cosmic furnace that creates light and color and movement on a scale that dwarfs any human creation. A reminder that even the most extreme environments in the universe can possess their own form of terrible beauty. Super-Earth oceans with gentle tidal rhythms create the most peaceful water worlds imaginable, where increased gravity pulls the seas into deeper, calmer basins that stretch beyond the horizon. These worlds, 1.5 to twice the size of Earth, possess oceans that are hundreds of miles deep, creating underwater landscapes of breathtaking tranquility where pressure and depth combine to form environments of perfect stillness. The increased gravity on these super-Earth ocean worlds creates tides that are more predictable and gentle than anything we experience on Earth. The massive pull of these larger worlds draws the water into stable patterns that change slowly and rhythmically, like the breathing of a sleeping giant. These deep tides would create vast underwater currents that flow in patterns so regular you could set a clock by them, carrying nutrients and warmth around the planet in cycles that have remained unchanged for millions of years. The underwater mountains on these deep ocean worlds would rise from abyssal plains so far below the surface that they exist in permanent darkness. Yet their peaks might still be thousands of feet below the ocean surface. These seamounts would be covered in bioluminescent life that has never known sunlight, creating underwater galaxies of living stars that pulse and twinkle in the eternal night of the deep sea. The increased pressure at these depths would create unique forms of life that exist nowhere else in the universe. The surface of these super-Earth oceans would be remarkably calm due to the deep water and stable tidal patterns. Waves would be gentle and regular, never reaching the violent extremes we sometimes see on Earth because the immense depth of water acts as a buffer against atmospheric disturbances. The ocean surface would be like a vast mirror that reflects alien skies with barely a ripple, creating a sense of infinite peace that extends in all directions. The most beautiful feature of these deep ocean worlds would be their thermal layers. The increased gravity would create distinct temperature zones at different depths, each supporting its own unique ecosystem. Near the surface, where starlight can penetrate, there might be floating forests of kelp-like organisms that sway gently in the mild currents. In the middle depths, bioluminescent creatures would create layers of living light that shift and pulse like slow aurora. And in the deepest trenches, where pressure creates exotic chemistry, entirely alien forms of life might exist in conditions we can barely imagine. Volcanic glass worlds shimmer in the light of young, energetic stars, their surfaces covered in obsidian plains that stretch from horizon to horizon like cosmic mirrors. These worlds formed during periods of intense volcanic activity when their surfaces were repeatedly flooded with lava that cooled rapidly in the vacuum of space, creating landscapes of incredible smoothness and beauty. The volcanic glass on these worlds would be unlike any surface we know. Perfectly smooth and reflective, it would create an environment where walking feels like floating across a mirror that reflects not just your image, but the entire sky above. The glass would be so pure and clear that during the day it would be nearly invisible, creating the illusion that you're walking on solidified air. At night, it would reflect the stars so perfectly that the boundary between ground and sky would disappear entirely. The colors in this volcanic glass would be determined by the trace elements present during its formation. Iron might create glass with deep green hues that shift and change as you move across the surface. Copper could produce brilliant blues and turquoises that seem to glow with their own inner light. Some areas might contain multiple elements, creating glass that displays rainbow patterns that shift and dance as the angle of the light changes throughout the day. The weather on volcanic glass worlds would create temporary art installations across the surface. When rare rains fall, the water would bead up on the glass like mercury, creating patterns of droplets that roll and combine in ways determined by the microscopic variations in the surface. These water patterns would be temporary masterpieces that exist for only hours before evaporating, leaving the glass surface clean and perfect once again. The most peaceful aspect of these glass worlds would be their perfect silence. Sound would behave strangely on such smooth surfaces, either reflecting cleanly or being absorbed completely depending on the angle and frequency. The result would be an environment where your own footsteps might echo clearly in some places, while being completely muted in others, creating an acoustic landscape as varied and interesting as the visual beauty of the endless glass plains. The sunsets on volcanic glass worlds would be spectacular beyond description. As the star sets, its light would be reflected and refracted by the glass surface in ways that create multiple images of the sun scattered across the landscape. The entire world would become a hall of mirrors where a single sunset becomes dozens of sunsets, each one slightly different, each one perfectly clear and brilliant against the dark glass surface. Worlds with photosynthetic atmospheres glow softly with the light of billions of airborne organisms that have evolved to harvest energy directly from their star's radiation. These remarkable planets have developed atmospheric ecosystems where microscopic life forms float freely in the air, creating skies that seem to pulse and breathe with living light. The photosynthetic organisms in these atmospheres would be so numerous that they would actually change the color and quality of the sky itself. During the day, when these aerial life forms are most active, the sky might take on shades of green and gold as the organisms harvest light and convert it into energy. The atmosphere would literally glow with the life it contains, creating a world where the boundary between air and living tissue becomes beautifully blurred. The weather patterns on these worlds would be influenced by the living atmosphere in ways that create incredibly stable and gentle conditions. The photosynthetic organisms would moderate temperature by absorbing excess heat during the day and releasing it slowly at night, preventing extreme temperature swings and creating climates that are more stable than anything we know on lifeless worlds. The organisms would also help regulate atmospheric composition, maintaining perfect balances of gases that support their own existence and create ideal conditions for any surface life that might exist. The most remarkable feature of these worlds would be their response to their star's daily cycle. As the star rises, the atmospheric organisms would become more active, causing the entire sky to gradually brighten with living light. This biological aurora would reach its peak at midday when the organisms are processing the most energy, then slowly fade as the star sets and the organisms enter their rest phase. The entire world would pulse with a gentle rhythm that mirrors the heartbeat of its living sky. The rain on these worlds would be unlike anything we could imagine. When moisture condenses in the living atmosphere, it would carry with it some of the airborne organisms, creating precipitation that is literally alive. This living rain would nourish any surface life forms and might even carry genetic information between different parts of the planet, allowing the aerial ecosystem to communicate and evolve in ways that span continental distances. The night sky on photosynthetic atmosphere worlds would be softly illuminated by the bioluminescent activity of the atmospheric organisms. Even after the star sets, the sky would continue to glow faintly with the stored energy being processed by the aerial life forms. This gentle luminescence would be enough to see by, creating nights that are never truly dark, but instead exist in a state of perpetual twilight that is both peaceful and magical. Worlds with crystalline water exist where unique atmospheric pressure and temperature conditions have created forms of ice that are transparent as glass, but stable at temperatures that would normally melt ordinary ice. These remarkable planets have solved the paradox of having solid water surfaces that remain clear and beautiful under conditions that would create cloudiness and opacity in normal ice. The crystalline ice on these worlds would be so clear that oceans would appear to be made of liquid glass that has been frozen in time. You could look down through hundreds of feet of this transparent ice and see the ocean floor as clearly as if you were looking through air. Fish-like creatures swimming beneath the ice would appear to be floating in space, creating the illusion of aerial life forms that swim through crystal skies. The formations created by this crystalline water would be architectural marvels that put human engineering to shame. Ice caves would be like cathedrals carved from pure crystal, with formations that focus and direct light in ways that create natural spotlights and rainbow displays throughout the underground chambers. These caves would be places where light and ice collaborate to create beauty that seems almost supernatural in its perfection. The surface of crystalline water worlds would create unique optical effects as the star's light passes through the transparent ice. Depending on the thickness and structure of the ice formations, different areas of the planet might act like enormous lenses that focus starlight into beams and patterns that move across the landscape as the world rotates. The entire surface would become a living light show that changes throughout the day as the angle of the light shifts and moves. The most peaceful aspect of these worlds would be their incredible clarity and purity. Everything would be visible and transparent, creating environments where there are no hidden corners or mysterious shadows. The crystalline ice would preserve everything perfectly, creating a world where ancient formations remain unchanged for millions of years. Like a cosmic museum where the history of the planet is preserved in perfect crystal clarity, the weather on crystalline water worlds would create temporary sculptures that appear and disappear as conditions change. When the atmospheric pressure or temperature shifts slightly, new formations of crystalline ice would grow in patterns determined by the exact conditions present at that moment. These formations would be incredibly beautiful and incredibly temporary, existing for perhaps only hours or days before melting back into the crystalline sea. Tide-locked desert worlds exist in a state of perfect division between scorching heat and freezing cold. But along the terminator line between these extremes lies a narrow band of perfect temperature where conditions are ideal for the most peaceful desert landscapes imaginable. These twilight deserts exist in perpetual sunset, where the star hangs forever on the horizon and paints the sand dunes in colors that never change. The sand on these twilight desert worlds would be unlike any sand on Earth. Constant exposure to stellar radiation on the day side of the planet creates particles that have been fused and reformed over millions of years, producing grains that are perfectly spherical and incredibly smooth. When gentle winds carry this sand into the twilight zone, it creates dunes that flow like liquid silk, forming and reforming in patterns of mathematical precision and beauty. The wind patterns in the twilight zone create a natural air conditioning system that maintains perfect temperatures throughout this narrow band of habitability. Hot air from the day side meets cold air from the night side along the terminator line, creating gentle breezes that flow in predictable patterns and never become violent storms. These winds carry the perfectly formed sand grains in patterns that create dunes which sing with musical tones as the grains slide and shift against each other. The most beautiful feature of these twilight desert worlds would be their sand gardens, natural formations where the wind has sorted different types of sand grains into patterns that create natural art installations across the desert floor. Heavy grains might collect in one area while lighter grains are carried elsewhere, creating designs that look like they were carefully planned by cosmic artists but are actually the result of millions of years of patient wind action. The sky above these twilight deserts would be a masterpiece of atmospheric optics. With the star perpetually on the horizon, the atmosphere would act like a natural prism, breaking the light into subtle color gradations that shift slowly across the sky throughout the day. The desert surface would reflect these colors, creating an environment where everything is bathed in warm, golden light that seems to make the very air glow with peaceful energy. The silence on these twilight desert worlds would be profound and healing. With no water to create weather sounds, no vegetation to rustle in the wind, and atmosphere so thin that sound travels only short distances, these worlds would exist in a state of acoustic perfection where every sound is clear and pure. The only sounds would be the gentle whisper of sand grains moving in the wind and the distant musical tones of the singing dunes, creating a natural soundtrack that promotes deep relaxation and contemplation. Worlds orbiting brown dwarf stars exist in a realm between planet and star, warmed by the gentle heat of failed suns that burn with the intensity of cosmic campfires. These brown dwarfs never achieve the nuclear fusion of true stars, but they still generate enough heat to warm nearby worlds with infrared radiation that creates the most gentle and soothing form of stellar energy imaginable. The light from brown dwarf stars would be predominantly in the infrared spectrum, invisible to human eyes but felt as gentle warmth on the skin. Worlds orbiting these dim stars would exist in perpetual twilight, warmed by invisible fires that heat without burning, creating environments where everything exists in a state of comfortable thermal equilibrium. The temperature differences between day and night would be minimal because the brown dwarf's heat penetrates deeply and evenly, creating incredibly stable climate conditions. The atmospheres of brown dwarf worlds would be heated from within by the thermal radiation, creating weather patterns that are driven by gentle temperature gradients rather than violent convection. Clouds would form and dissipate slowly, creating sky patterns that change with the patience of meditation. Rain, when it falls, would be warm and gentle, heated by its passage through the thermally active atmosphere. The most peaceful aspect of these worlds would be their relationship with their brown dwarf parent. Unlike the violent radiation of true stars, brown dwarfs emit energy in forms that are nurturing rather than destructive. Any life that evolved on these worlds would be adapted to exist in gentle warmth and soft light, creating ecosystems that might be incredibly delicate and beautiful, like cosmic greenhouse gardens tended by the patient heat of their dim brown dwarf sun. The auroras on brown dwarf worlds would be subtle and beautiful, created by the interaction between the world's magnetic field and the gentle particle streams from the brown dwarf. These displays would be visible primarily in the infrared spectrum, creating curtains of warm light that would be felt as much as seen, wrapping the world in blankets of luminous energy that pulse gently through the atmosphere. The seasons on brown dwarf worlds would be determined not by orbital distance but by small changes in the brown dwarf's energy output, creating climate variations so gentle that they would be barely perceptible, except over long periods of time. These subtle seasonal changes would create environments where life could exist in perfect stability, supported by the constant, gentle warmth of their cosmic hearth fire, burning patiently in the darkness of space. Helium rain worlds drift through regions of space where the unique atmospheric chemistry creates precipitation of liquid helium that falls like silver tears from alien skies. These worlds exist in temperature ranges where helium can exist as a liquid, creating weather patterns and surface features that are unlike anything in our experience. The helium rain on these worlds would fall in droplets that are perfectly spherical and incredibly light, creating precipitation that seems to float down from the sky rather than fall. Each droplet would be like a tiny mirror, reflecting the world around it in perfect miniature before merging with others to form streams and pools of liquid helium that flow across the landscape like rivers of liquid mercury. The atmosphere on helium rain worlds would create unique acoustic properties, where sound travels in ways that transform all audio into something ethereal and musical. The light helium atmosphere would make voices higher and clearer, while also creating resonance effects that turn every sound into a note in a cosmic symphony. Walking across these worlds would be like moving through a living musical instrument where every step creates harmonic tones that blend with the gentle patter of helium rain. The surface features on these worlds would be shaped by the unique properties of liquid helium, which remains fluid at temperatures where most other substances would be solid. Liquid helium rivers would carve valleys and canyons through landscapes made of materials that are stable at these extreme temperatures, creating geological features that are both familiar in their basic structure and completely alien in their composition and behavior. The most remarkable aspect of helium rain worlds would be their interaction with light. The liquid helium would act as a natural lens, bending and focusing light in ways that create optical effects throughout the landscape. Pools of liquid helium would become natural magnifying glasses, while flowing streams would create moving patterns of focused light that dance across the ground like living creatures made of illumination. The evaporation patterns on these worlds would create temporary weather phenomena where pools of liquid helium slowly disappear into the atmosphere, creating localized fog effects and atmospheric disturbances that are incredibly gentle and beautiful. These evaporation cycles would be so regular and predictable that they would create natural clocks, marking the passage of time through the patient rhythm of helium rain and helium fog. Mirror worlds covered in naturally occurring metallic surfaces reflect their stars' light with such intensity that they shine like beacons across interstellar space. These remarkable planets formed in regions rich in metallic elements that crystallized into surfaces of incredible reflectivity, creating worlds that are simultaneously mirrors and planets, reflecting the cosmos back upon itself in displays of perfect symmetry. The metallic surfaces on these worlds would be polished to perfection by millions of years of cosmic weather, creating planetary mirrors so smooth and reflective that they would be visible from incredible distances. These worlds would be like cosmic lighthouses, their reflected starlight creating beams that sweep across space as the planet rotates, announcing their presence to any observers in distant star systems. The landscape on mirror worlds would be one of infinite reflections, where every hill and valley is duplicated in perfect reverse by its reflection in the metallic ground. Walking across such a world would be like moving through a hall of mirrors that extends to the horizon, creating visual experiences that challenge the mind's ability to distinguish between reality and reflection. The effect would be both beautiful and meditative, like existing in a world made entirely of contemplation. The weather on mirror worlds would create temporary disruptions in the perfect reflectivity as dust and atmospheric particles settle on the metallic surface. Rain would act like a cosmic cleaning service, washing the mirrors clean and restoring their perfect reflectivity in patterns that sweep across the planet's surface. These cleaning cycles would create temporary variations in the world's brightness as seen from space, like a cosmic lighthouse with a variable beam. The most peaceful aspect of mirror worlds would be their relationship with light itself. These worlds would exist in perfect harmony with their star, reflecting its energy back into space in patterns that create complex interference effects and light displays that extend far beyond the planet's atmosphere. The entire system would become a cosmic optical instrument, using the planet as a mirror to create light sculptures in space that are visible across interstellar distances. The sunsets on mirror worlds would be infinite experiences where a single sun becomes hundreds of suns reflected in every surface. The metallic landscape would capture and reflect the setting star from every angle, creating a sunset that surrounds you completely and extends in all directions. It would be like being inside a sunset rather than simply observing one, wrapped in light that comes from everywhere at once in a display of perfect, radiant beauty. Planetary nurseries exist where new worlds are still being born from swirling disks of cosmic dust and gas. These protoplanetary systems are vast construction zones where gravity slowly gathers material into clumps that will eventually become fully formed planets. The process unfolds over millions of years with the patience that transforms chaos into order through the gentle persistence of physical laws. In these stellar nurseries, young planets emerge like flowers blooming in slow motion. The disk of material around the newborn star glows with the heat of formation, creating spirals and gaps where infant worlds are clearing their orbital paths. The largest planets form first, their growing gravity pulling in more and more material until they become the giants that will shape their entire solar system for billions of years to come. The dust in these formation regions would be warm to the touch, heated by the energy of countless collisions as particles stick together to build the foundation of future worlds. This cosmic construction happens in perfect silence, with no sound to mark the moment when a collection of dust becomes something that might one day be called a planet. It's the universe's way of dreaming new worlds into existence. The most beautiful aspect of these planetary nurseries is their promise of infinite possibility. Each swirling eddy in the disk might become a world of diamond rain or crystal forests. Each gravitational disturbance could be the birthplace of a future ocean world where alien life will eventually swim beneath foreign stars. These formation zones are where the future of the galaxy is being written in dust and gravity. The baby planets in these systems would be hot and molten, still glowing from the heat of their formation. Their surfaces would be seas of liquid rock that slowly cool and solidify over geological time. Volcanic activity would be constant but gentle, like the breathing of worlds that are learning how to exist. These infant planets are writing the first chapters of stories that will continue for billions of years. Worlds with variable gravity experience regular changes in their gravitational pull. due to their elliptical orbits around binary star systems. As these planets travel through their complex orbital dance, the combined gravitational influence of their two parent stars creates environments where weight itself becomes a changing, flowing thing that ebbs and flows like cosmic tides. During periods of high gravity, when the planet passes close to both of its stars, everything becomes heavier and more grounded. Creatures on such worlds might experience a sense of increased weight and stability, while any atmosphere becomes denser and more substantial. Mountains would settle slightly under the increased pull, and any liquid on the surface would be drawn into deeper, more stable basins. When the orbital dance carries the planet farther from its binary stars, the gravity would lighten and everything would become more buoyant. Atmospheric pressure would decrease, creating conditions where flight becomes easier and where any life forms might experience a sense of weightlessness that comes and goes in predictable cycles. It would be like living on a world that breathes gravitationally, expanding and contracting its pull in rhythm with its complex orbit. The weather patterns on variable gravity worlds would be unlike anything we could imagine. As gravity changes, so would atmospheric density and pressure, creating weather systems that intensify and diminish in cycles that mirror the gravitational variations. Storms might become more powerful during high gravity periods when the dense atmosphere can hold more energy, then dissipate during low gravity phases when the thin air cannot sustain violent weather. The most peaceful aspect of these worlds would be their predictable cycles. The gravitational changes would follow the precise mathematics of orbital mechanics, creating rhythms that any inhabitants could learn to anticipate and adapt to. Life on such worlds would evolve to take advantage of both the heavy and light phases, perhaps becoming more active during periods of reduced gravity and more contemplative during times of increased weight. The landscape itself would be shaped by these gravitational cycles, with erosion and geological processes that speed up and slow down in harmony with the changing pull of the binary stars. Rivers might flow faster and carve deeper during high gravity periods, then slow to gentle streams during light phases. The entire world would exist in a state of gentle flux, never quite the same from one orbital period to the next. Magnetic field worlds exist where powerful planetary magnetospheres create visible aurora displays that never fade. These planets possess magnetic fields so strong and complex that they turn their entire atmosphere into a canvas for continuous light shows that paint the sky in colors that shift and dance throughout both day and night. The aurora on these magnetic worlds would be unlike the brief displays we occasionally see on Earth. Instead, they would be permanent features of the sky, as constant and reliable as the stars themselves. The magnetic field would channel charged particles from their star into streams of light that flow across the atmosphere in patterns that mirror the invisible magnetic lines of force surrounding the planet. Different regions of these worlds would experience different types of aurora depending on their relationship to the magnetic field lines. Near the magnetic poles, the displays would be intense and dramatic, with curtains of light that reach from the ground to the edge of space. In the equatorial regions, the aurora might appear as gentle glows that wash across the entire sky, turning night into a soft twilight that never fully darkens. The colors of the permanent aurora would depend on the atmospheric composition and the energy of the charged particles being channeled by the magnetic field. Some regions might glow with steady green light, while others pulse with blues and purples and reds that shift in waves across the sky. The entire planet would become a living light sculpture that is visible from space as a glowing orb wrapped in constantly moving veils of luminescence. The most meditative aspect of these magnetic worlds would be the way the aurora responds to changes in the stellar wind. When their star becomes more active, the aurora would intensify and become more dynamic. During quiet periods, the displays would become softer and more gentle, creating a direct visual connection between the planet's atmosphere and the activity of its parent star. Life on magnetic field worlds would evolve under skies that are never dark and never static. Any creatures that developed eyes would see a world where the boundary between Earth and sky is blurred by constant light displays. Navigation would be guided not by fixed stars, but by the flowing patterns of aurora that move across the heavens in predictable cycles, tied to the planet's magnetic rhythm. Resonance worlds orbit their stars in mathematical harmony with other planets in their system, creating gravitational relationships so precise that their movements become a form of cosmic music. These orbital resonances lock the planets into patterns where they complete exact ratios of orbits, like 3 orbits for every 2 of a neighboring world, creating celestial clockwork of incredible precision and beauty. The gravitational influence of planets, locked in orbital resonance, creates tidal effects that pulse in perfect rhythm across their surfaces. These resonance tides would be incredibly regular and predictable, rising and falling in patterns that could be calculated thousands of years in advance. Any oceans on these worlds would experience tidal rhythms more complex and beautiful than anything we know on Earth. The seasons on resonance worlds would be influenced not just by their own orbital characteristics, but by their gravitational relationship with their planetary siblings. As the resonant worlds align and separate in their cosmic dance, they would experience subtle changes in their orbital energy that could create seasonal variations of incredible subtlety and complexity. These gravitational seasons would overlay the normal thermal seasons to create climate patterns of mathematical beauty. The most remarkable feature of resonance worlds would be their long-term stability. The gravitational relationships that lock them into their precise orbital ratios also protect them from disruption, creating planetary systems that could remain unchanged for billions of years. These worlds exist in gravitational sweet spots where the forces are perfectly balanced, allowing them to maintain their cosmic choreography indefinitely. The night sky from resonance worlds would tell the story of their orbital relationship with mathematical precision. The other planets in their system would appear at predictable locations and intervals, creating celestial calendars that mark the passage of time with clockwork accuracy. Observers on these worlds could predict eclipses, conjunctions, and planetary alignments centuries in advance because the system operates with the precision of a cosmic timepiece. The tidal effects on resonance worlds would create unique geological features where the regular gravitational pulses have carved the landscape into patterns that reflect the orbital mathematics. Coastlines might be sculpted into regular formations, and any geological processes would be influenced by the predictable tidal stresses that flex the planet's crust, in rhythm with its orbital dance. Subsurface ocean worlds hide vast seas beneath shells of ice that have never seen starlight. These hidden oceans contain more water than all the surface seas of Earth combined, existing in perfect darkness and maintained in liquid form by the gentle heat rising from their planet's core or by the tidal forces exerted by nearby massive planets. The hidden oceans beneath these ice shells would be places of absolute tranquility, where no storms disturb the surface because there is no surface exposed to atmospheric disturbance. The water would be incredibly pure, filtered through the ice shell above and isolated from any contamination from space. These buried seas would be like vast underground cathedrals filled with liquid silence. The ice shells protecting these hidden oceans would be landscapes of incredible beauty, carved by the slow movement of the ocean beneath into formations that tell the story of millions of years of patient geological activity. Pressure ridges would mark places where the ocean currents have pushed against the ice from below, while smooth plains would show areas where the ice has remained stable and undisturbed. The most fascinating aspect of these subsurface oceans would be their potential for harboring life forms that have never known the light of a star. Any creatures that evolved in these hidden seas would exist in a world of eternal night, perhaps developing forms of bioluminescence that would turn the dark waters into galaxies of living stars. These deep ocean worlds might contain ecosystems more alien and wonderful than anything that exists on any surface. The currents in subsurface oceans would be driven by the heat rising from the planet's core, creating circulation patterns that could persist for millions of years without change. These thermal currents would distribute heat and nutrients throughout the hidden sea, creating environments that are incredibly stable and conducive to the slow evolution of complex life forms. The boundaries between the liquid ocean and solid ice would be regions of unique beauty where the water slowly freezes and melts in response to tidal heating and thermal currents. These transition zones would be like underwater glaciers, where formations of ice grow and dissolve in patterns that create natural sculptures of incredible delicacy and temporary beauty. Storm giant worlds experience weather systems so large and long-lasting that individual storms persist for centuries, becoming permanent features of their atmospheric landscape. These massive weather phenomena are driven by the planet's rapid rotation and the enormous energy available in their thick atmospheres, creating cyclones that dwarf anything we see on Earth. The great storms on these worlds would be large enough to swallow entire continents, yet they would be surprisingly gentle when experienced from within. The vast scale of these weather systems means that the pressure gradients and wind speeds, while enormous in absolute terms, would change gradually across the massive storm structure. Standing inside one of these giant storms would be like existing within a slowly rotating atmospheric cathedral. The eye walls of these century storms would be regions of perfect calm that could be hundreds of miles across. Within these peaceful centers, the air would be still and clear while the storm walls would rise like atmospheric mountains all around the horizon. These storm eyes would be natural safe harbors where any life on the planet could find refuge from the slowly circulating winds that surround them. The lightning displays in these massive storms would be spectacular beyond description, with electrical discharges that stretch for thousands of miles across the storm structure. The scale of these lightning bolts would be so vast that individual strikes could last for minutes, creating sustained displays of electrical energy that turn the entire storm into a living light show that pulses with the rhythm of the planet's atmospheric heartbeat. The most peaceful aspect of these storm worlds would be the predictability of their weather patterns. Because the storms are so large and stable, they create atmospheric conditions that remain essentially unchanged for centuries. any inhabitants would know exactly what weather to expect in any location, creating climates that are as reliable as clockwork despite being driven by some of the most powerful weather systems in the universe. The interaction between multiple giant storms would create atmospheric boundaries where different weather systems meet and exchange energy. These boundary regions would be places of unique beauty where different wind patterns create complex atmospheric sculptures that persist for decades before slowly shifting and changing as the great storms continue their patient dance around the planet. Twilight archipelago worlds consist of chains of islands that exist along the terminator line of tidally locked planets, creating networks of habitable land surrounded by seas that transition from ice to steam as they stretch between the frozen night side and the scorching day side of the planet. These island chains would be oases of perfect temperature situated in the narrow band where the planet's rotation has been stopped by tidal forces, leaving one side in permanent day and the other in eternal night. The islands would exist in perpetual sunset conditions, where the star hangs forever on the horizon and paints the sky in colors that never change. Each island would be a small world unto itself, with microclimates determined by its exact position along the terminator line. The seas surrounding these twilight islands would be unlike any ocean we know. On the night side, the water would be frozen solid, creating ice fields that stretch to the horizon. On the day side, the seas would boil and steam, creating clouds that drift toward the night side where they freeze and fall as snow. The islands along the terminator would be surrounded by liquid water that is the perfect temperature for life. The weather patterns around these island chains would be driven by the temperature differences between the hot and cold sides of the planet, creating trade winds that blow consistently from the cold side toward the hot side. These predictable wind patterns would make sailing between the islands a gentle and reliable experience, with breezes that never become violent storms because the temperature gradients change gradually across the terminator zone. The most beautiful feature of these twilight archipelagos would be their diversity within the narrow habitable zone. Islands closer to the day side would be warm and humid, with tropical conditions and lush vegetation. Islands nearer the night side would be cooler and more temperate, with forests and grasslands that thrive in the cooler conditions. The middle islands would experience perfect Mediterranean-like climates where the temperature never varies. The sunsets on these island worlds would be eternal experiences that never end because the star never moves from its position on the horizon. Each island would have its own unique sunset view, determined by its topography and its exact location along the terminator line. Some islands might experience sunset views that last for hours, while others might have brief but incredibly intense displays, as the star appears to rest on the ocean horizon. The coral reefs surrounding these twilight islands would be unlike any marine ecosystem we know, adapted to exist in water that maintains a constant temperature and receives consistent amounts of sunlight. These reefs would grow in patterns determined by the unique lighting conditions, creating underwater gardens that are perfectly adapted to their twilight environment and might harbor forms of marine life that exist nowhere else in the universe. Resonant moon systems orbit their parent planets in gravitational harmony that creates tidal rhythms of incredible complexity and beauty. These moon systems are locked into orbital relationships where the periods of their orbits create exact mathematical ratios, causing their gravitational influences to combine and separate in patterns that create tidal effects of stunning regularity and power. The tides on worlds with resonant moon systems would rise and fall in patterns that reflect the orbital mathematics of their satellite companions. Instead of simple, twice-daily tides, these worlds might experience tidal cycles that unfold over weeks or months as the moons align and separate in their cosmic dance. The highest tides would occur when the moons align to combine their gravitational pull, creating tidal ranges that could be hundreds of feet in amplitude. The coastal landscapes on these worlds would be shaped by the extreme tidal ranges into formations that exist nowhere else in the universe. Vast tidal pools would be exposed during low tide, creating temporary ecosystems that appear and disappear with the rhythm of the moon dance. Coastal cliffs would be carved into step-like formations that mark the various tidal levels created by different combinations of moon alignments. The most peaceful aspect of resonant moon systems would be their mathematical predictability. The tidal patterns would follow precise orbital mechanics that could be calculated thousands of years in advance, creating natural calendars that mark the passage of time with astronomical precision. Any life on these worlds would evolve to take advantage of the predictable tidal cycles, perhaps timing reproduction and migration to coincide with specific tidal events. The night sky on worlds with resonant moon systems would be a constantly changing display of celestial mechanics in action. The moons would appear to dance across the sky in patterns that repeat over long cycles, creating natural planetariums where the orbital relationships are visible to the naked eye. Observers could watch the moons approach conjunction and see the mathematical relationships that govern their movements played out in real time across the heavens. The auroras on these worlds would be influenced by the complex magnetic interactions between the planet and its multiple moons, creating light displays that pulse and change in rhythm with the orbital resonances. The magnetic fields of the moons would interact with the planet's magnetosphere to create aurora patterns that are more complex and beautiful than anything seen on worlds with single moons or no moons at all. The gravitational effects of resonant moon systems would extend beyond just tides to influence weather patterns, atmospheric circulation, and even geological activity. The regular gravitational pulses would create atmospheric tides that modulate wind patterns and weather systems, while the tidal flexing of the planet's crust would create gentle geological rhythms that pulse in harmony with the orbital dance of the moons overhead. Plasma wind worlds drift through regions of space where charged particles create atmospheric phenomena that turn the entire planet into a living electrical display. These remarkable worlds exist in the path of stellar winds so dense with charged particles that their atmospheres become conductors, creating environments where electricity flows like water and lightning becomes as common as rain. The plasma winds on these worlds would create aurora displays that cover the entire planet rather than being confined to polar regions. The charged atmosphere would glow with colors that shift and change as different elements become ionized by the constant electrical activity. The entire world would exist inside what is essentially a gentle electrical storm that never ends, creating skies that pulse with soft light in rhythm with the fluctuations in the stellar wind. The weather on plasma wind worlds would be fundamentally electrical in nature. Instead of clouds made of water vapor, these worlds would have formations of charged particles that create their own electromagnetic fields. These plasma clouds would drift across the sky like luminous jellyfish, glowing with their own internal light and occasionally releasing gentle electrical discharges that arc between different cloud formations in displays of natural beauty. The surface of these worlds would be constantly bathed in the soft glow of the electrified atmosphere, creating lighting conditions that never fully darken into night. The electrical activity would be gentle enough to be safe, but spectacular enough to create an environment where every surface seems to glow with its own inner light. Walking across such a world would be like moving through a living neon sign that stretches to the horizon. The most meditative aspect of plasma wind worlds would be the constant, gentle humming sound created by the electrical activity in the atmosphere. This electromagnetic music would be heard and felt throughout the planet, creating a natural soundtrack that promotes deep relaxation and contemplation. The sound would change subtly as the stellar wind varies in intensity, creating a cosmic symphony that reflects the electrical weather patterns flowing through the charged atmosphere. Desert glass worlds sparkle under the light of binary star systems, where the combined radiation has transformed vast sandy regions into landscapes of natural crystal formations. These worlds experience periods in their history when intense stellar radiation fused sand into glass sculptures that cover entire continents, creating desert environments that shimmer and gleam like cosmic jewelry stores. The glass formations on these worlds would take every conceivable shape, from delicate spires that ring like bells in the wind to vast sheets of colored glass that stretch beyond the horizon. The binary stars would heat different regions at different times as the world rotates, causing the glass to expand and contract in ways that create musical tones that echo across the desert landscapes. These glass deserts would be places where geology and music merge into single experiences. The sandstorms on glass desert worlds would be unlike any weather phenomenon we could imagine. Instead of particles of rock and dust, these storms would consist of tiny glass beads that have been worn smooth by millions of years of wind action. These glass sandstorms would create displays of incredible beauty as billions of tiny prisms catch and scatter the light of the binary stars, turning violent weather into moving rainbows that dance across the landscape. The oases on these worlds would be formations where underground water has created pockets of humidity that have prevented the sand from fusing into glass. These natural gardens would be surrounded by walls of crystal formations, creating protected environments where life could evolve in the shelter provided by the glass desert. These oases would be like jeweled settings where organic life exists in harmony with the crystalline landscape that surrounds it. The most peaceful feature of glass desert worlds would be their thermal regulation properties. The glass formations would absorb heat during the day when the binary stars are overhead, then release it slowly during the night, creating temperature conditions that remain remarkably stable despite the intense radiation from their dual suns. The glass landscape would act like a natural climate control system that moderates the extreme conditions that might otherwise make these worlds uninhabitable. The sunrise on glass desert worlds would be spectacular events where the light of the binary stars is refracted and reflected by millions of glass formations simultaneously. The entire desert would light up like a vast chandelier, with each glass structure contributing its own pattern of reflected light to create displays that are visible from orbit. These binary sunrises would paint the landscape in colors that exist nowhere else in the universe. Atmospheric river worlds experience weather patterns where streams of water vapor flow through the atmosphere like aerial highways, creating precipitation patterns that follow predictable paths across continents with the regularity of clockwork. These atmospheric rivers would be visible from space as bands of cloud that stretch from ocean to ocean, carrying moisture in patterns that have remained stable for millions of years. The rain patterns on atmospheric river worlds would be more like scheduled events than random weather. The aerial rivers would follow the same path season after season, delivering water to specific regions with such reliability that any life on these worlds could set calendars by the arrival of the moisture-bearing atmospheric streams. Desert regions would bloom into temporary gardens when their scheduled atmospheric river arrives, then return to dormancy until the next delivery of water. The atmospheric rivers themselves would create unique cloud formations that stretch for thousands of miles in narrow bands across the sky. These aerial highways would be visible as streams of cloud that flow overhead like rivers in the sky, carrying their cargo of water vapor from the evaporation zones over the oceans to the precipitation zones over the continents. Flying through these atmospheric rivers would be like swimming through streams of mist that extend far above the normal cloud layer. The most beautiful aspect of these worlds would be the way the atmospheric rivers create temporary connections between distant regions. A single river of vapor might carry moisture from one continent to another, creating brief periods when distant ecosystems share the same water source. This atmospheric sharing would create biological connections across vast distances, allowing genetic material and nutrients to travel between isolated regions through the medium of the aerial rivers. The weather forecasting on atmospheric river worlds would be incredibly precise because the rivers follow such predictable paths. Any inhabitants could know weeks in advance when rain would arrive in their region and exactly how much moisture the atmospheric river would deliver. This predictability would allow for perfect agricultural planning and would create cultures that live in harmony with the scheduled delivery of water from the sky. Singing crystal worlds resonate with harmonic frequencies created by wind passing through vast fields of naturally occurring crystal formations that have grown into shapes perfectly tuned to create musical tones. These worlds would be places where geology and music merge into single experiences, creating planetary scale instruments that play themselves whenever the wind blows. The crystal fields on these worlds would be organized into natural orchestras, where different regions produce different musical scales and harmonies. Valley floors might be covered in crystals tuned to low bass frequencies that provide the fundamental rhythm for the planetary music, while hillsides could be adorned with smaller crystals that create the melody lines and harmonic overtones. The entire world would be a musical composition written in stone and played by the wind. The wind patterns on singing crystal worlds would be influenced by the musical resonances created by the crystal formations themselves. The sound waves generated by the crystals would create pressure variations in the atmosphere that influence wind direction and speed, creating feedback loops where the music shapes the weather and the weather shapes the music. This would result in atmospheric conditions that are incredibly stable and predictable because they are locked into harmonic relationships. The most meditative aspect of these worlds would be the way the crystal music changes with the seasons and weather patterns. During gentle weather, the crystals would produce soft, soothing tones that promote relaxation and contemplation. When stronger winds blow, the formations would create more dramatic musical passages that reflect the energy and power of the atmospheric conditions. The entire world would become a mood ring made of music that reflects the emotional state of the planet's weather systems. The acoustic properties of singing crystal worlds would create natural amphitheaters where the crystal formations focus and amplify sound waves to create areas of perfect acoustic clarity. These natural concert halls would be places where even the softest sounds are clearly audible, while loud sounds are modulated and smoothed by the harmonic resonances of the crystal formations. Any vocalizations on these worlds would be enhanced and beautified by the musical properties of the crystalline environment. Gradient worlds exist where different regions experience vastly different environmental conditions due to their unique orbital or rotational characteristics, creating planets that are essentially multiple worlds combined into single entities. These gradient worlds would have regions that transition gradually from one extreme environment to another, creating bands of different climates and ecosystems that exist in harmony on the same planet. The temperature gradients on these worlds would create climate zones that transition so gradually that the boundaries between different environments are almost imperceptible. A journey from the hot regions to the cold regions would be like traveling through a natural climate control system where each step brings subtle changes in temperature, humidity, and atmospheric conditions. These gradual transitions would create incredible diversity within single worlds while maintaining perfect balance between different environmental zones. The atmospheric gradients would create weather patterns where different climate systems interact and exchange energy in ways that create incredibly stable overall conditions. Storm systems from hot regions would gradually dissipate as they move into cooler areas, while cold weather patterns would warm and moderate as they drift toward hotter zones. This atmospheric mixing would prevent any region from experiencing extreme weather because the gradient system naturally moderates all climatic conditions. The most peaceful aspect of gradient worlds would be their ability to provide perfect environmental conditions for any preference or need. Creatures or visitors could choose to live in the climate zone that suits them best, whether they prefer tropical warmth, temperate moderation, or cool conditions. The gradual nature of the transitions means that migration between climate zones would be comfortable and stress-free. The ecosystems on gradient worlds would be incredibly diverse because each climate zone would support different forms of life that are perfectly adapted to their specific environmental conditions. The transition zones between different gradients would be particularly rich in biodiversity because they would contain species adapted to variable conditions as well as migrants from the more stable zones on either side. The beauty of gradient worlds would lie in their incredible variety within unity. A single world would contain tropical beaches, temperate forests, alpine meadows, and polar landscapes, all existing in harmony and connected by gentle transitions that make the entire planet feel like a carefully designed garden where every possible environmental preference has been accommodated with perfect balance and natural flow. Harmonic resonance worlds exist where the orbital mechanics create gravitational rhythms that influence every aspect of the planet's behavior, from geological activity to atmospheric circulation to potential biological cycles. These worlds exist in gravitational sweet spots where multiple celestial influences combine to create environments that pulse with mathematical precision and cosmic harmony. The geological activity on harmonic resonance worlds would follow predictable cycles that reflect the gravitational rhythms created by their orbital relationships. Volcanic activity might increase and decrease according to the gravitational stresses created by planetary alignments, while tectonic activity would follow patterns that could be predicted using the same mathematics that govern the orbital mechanics. The entire planet would breathe geologically in rhythm with its celestial environment. The atmospheric circulation on these worlds would be influenced by the harmonic resonances in ways that create weather patterns of incredible regularity and beauty. High and low pressure systems would develop according to the gravitational cycles, creating seasonal patterns that are more precise than clockwork. The atmosphere would essentially become a musical instrument played by gravitational forces, creating weather symphonies that unfold with mathematical precision. The most remarkable feature of harmonic resonance worlds would be their long-term stability. The gravitational relationships that create the harmonic resonances also protect the planet from disruption, creating environments that could remain essentially unchanged for billions of years. These worlds would be cosmic safe harbors where complex ecosystems could evolve and develop over geological time periods without fear of catastrophic disruption. The tidal effects on harmonic resonance worlds would create patterns that influence every body of water on the planet simultaneously. Instead of simple tides that rise and fall twice daily, these worlds might experience complex tidal harmonies where different bodies of water pulse in different rhythms that combine to create overall patterns of incredible beauty and mathematical elegance. Coastal regions would be sculpted by these harmonic tides into formations that reflect the orbital mathematics in stone and sand. The potential for life on harmonic resonance worlds would be enhanced by the predictable environmental cycles that would allow biological systems to evolve in perfect synchronization with the planetary rhythms. Any life that did evolve would be incredibly well adapted to its environment because the environmental conditions would be so regular and predictable that evolutionary adaptation could achieve near perfect efficiency. And so our journey through the cosmos draws to a gentle close. We've drifted together past worlds of diamond rain and crystal forests, through oceans that stretch beyond horizons and deserts that sing in the stellar wind. Each of these distant realms carries its own quiet poetry written in the language of gravity and light, time and space. Perhaps some of these celestial wonders have lingered in your thoughts, or perhaps they've already dissolved into the soft embrace of approaching sleep. Either way is perfect. The universe will still be there tomorrow, vast and patient, filled with countless worlds we've yet to imagine. If you're still awake, you can explore another video when you're ready. But for now, let these distant planets carry you gently into dreams where you might walk on shores of liquid mercury or listen to the cosmic songs of singing crystals. Sleep well, and may your dreams be filled with starlight,